So this presentation is about troubleshooting BGP. I've angled it at as a beginner presentation rather than anything intermediate or advanced. What I'm trying to impart here is more about how you go about setting up good principles and practices with trying to do troubleshooting within BGP. So if you came looking for Merrick's presentation, it's not here. It's at the other side in Salon F. My name is Philip Smith. I work for Cisco. I live in Australia. Well, I have a house in Australia, but I spend most of my time, it seems, pretty much anywhere else in the world. So coming to visit you all here at NANOG is just one of the many things I do. Mostly work in the Asia-Pacific region, mostly with ISPs, mostly doing training, tuition, BGP, stuff like this. So, if you want to follow the presentation, the slides are actually up in two places. Given I gave Susan my presentation about 2 hours ago, I'm not sure if you've got the absolute latest slides or not. What may have been on the Merit website were just the draft up until about 2 hours ago. So, but what's on the Cisco FTP site is what I'm actually using here. I've made some subtle changes. So if you want to follow the presentation, the slides are there for you. Assumptions. Well, I'm going to assume that you actually know BGP. You've got a fairly basic working knowledge of the protocol. If you've never heard of BGP or never even really used it, and you're just coming here to try and learn a little bit, the presentation will be useful for you as well. But as I say, some of the principles may not make much sense until you've actually gained some experience of the protocol. And as it says there, and as I said before, please feel free to ask questions. The microphone is in the middle there. If you'd like to use the mic, please. Okay, there's really three parts of the presentation. The first bit, quite short, we're going to look at the fundamentals of troubleshooting. We're going to have a look at some of issues you can get with local configuration problems, i.e. within your own network. And then, depending on what time we have at the end, have a look at some of the internet reachability problems. So in other words, how you go about trying to do troubleshooting when it's not inside your network. Right, first thing is really all about trying to recognize what the problem is. Right? First step you've got to do is try and recognize what caused the problem. Now this is true for any troubleshooting anywhere whatsoever. BGP is not special in this case. But I've found in my, 10 to 15 years experience in the industry, when you mention the magic words BGP, people panic, especially if you're newcomers to it. And I suppose they do enter into a minor panic with good reason, because the use of BGP in your network determines your network connectivity. You break BGP, you break connectivity somehow for your network, your customers, and so forth. And of course, customers start complaining, and then everybody gets to know about it, especially your boss and the people who make money from your business. So I find quite often that the result of this is that people will work around problems in the most bizarre ways, sticking plaster, funny kind of configurations, just to try and work around the particular issue they have, rather than sitting down and trying to work methodically to fix the actual problem. Also, I mean, this is true for anything. I mean, this is not true, not necessarily just for BGP, but best troubleshooter is one who will learn from experience. And when you fixed your first problem, you feel great, which gives you incentive to go and fix other problems after that. And you have more confidence in doing this, so you just have more practice, you get better at doing it. The second one, mistakes. If you learn from your mistakes, well, when you do troubleshooting, you actually make a lot of mistakes. I mean, there's nobody I know who's actually sat down, able to do troubleshooting, and has never ever made a single mistake. I mean, you tend to learn a lot about what you're doing from mistakes that you make. And yes, you'll get better at it. You'll get better at learning, and you'll get better at the troubleshooting. And also, you learn from others as well. So learn what other operators say. There are plenty of BGP problems discussed on various mailing lists. Sometimes it appears on Nanog. Usually lists like ISP BGP and so forth. All these, we're discussing BGP issues, problems that people face. Look at some of the issues that people discuss, some of the problems and how they're solved. You can maybe use some of those for your own troubleshooting later on. And also the best troubleshooter will go about creating some basic principles. And those principles are based on what you've actually learned in the past. So you're kind of building up a historical record of what you've done. I mean, every problem is different, every network is different, so you can't really ask in public, how do I go about fixing such and such a problem? Because nobody will really have the identical situation, so the best they can do is give advice. If you can use this advice to figure out what's wrong in your network and then add it to your so-called database, then it makes solving problems much easier later on. Now, before I joined Cisco, I used to work at UUNet, and our network operations center, certainly for the UK operation, we used this type of thing. I didn't particularly want them coming running to me every time there was a BGP problem in the network. So we gave them a basic thing, encouraged them to go and try and figure out what the problem was, and learn from their own things. So every network operations center operator would actually access, I suppose, a little diary of the problems that they had, and they would use this diary to try and figure out what was wrong with the thing. So it's a so-called building a kind of knowledge base. And they all became pretty good troubleshooters. They didn't have to bother me or any of my network engineering team that much. Now, where can you actually have problems within BGP? Well, as with anywhere else, misconfiguration. Now, this misconfiguration could be caused by bad documentation, misunderstanding concepts, poor communication between colleagues or departments. I mean, that's all typical stuff. Human error, typos. I mean, you could be sleepy, you've just finished working 36 hours at some kind of big problem in the network. You're more likely to make typing mistakes then. You use the wrong commands, or the command completion didn't quite work as you expect. Just plain and simple accidents, poorly planned or executed maintenance activities, that's a favorite one, and plus all of the above misconfiguration problems. All can be human error. Technical problems, such as problems with the hardware. You may have some weird hardware fault that's causing something really strange to go wrong with BGP, but it looks like a routing protocol problem, but it actually could be something physical within the network or the equipment. Software problems, we all know. Inter-router link loads affecting protocol stability. In other words, the link is congested, BGP falls over. Now, I mean, you can say, well, BGP falls over, but why is the link congested? That's the type of thought process. More problem areas. Feature behavior, as I'd like to call it. Or it used to do this in one release, but you upgrade to what should be just a minor change to fix some bugs, and some behavior completely and absolutely changes and messes things up. Okay, that's another potential problem area. Interoperability issues, certainly if you're using different equipment in the network. You could be using, say, Cisco or Juniper or Zebra mixed up within your network. There could be interoperability issues. You can't just assume that, well, one is right and others are wrong. You've got to figure out the different interpretations of the BGP standard. And then, of course, the problems caused by things beyond your control. Your upstream ISP has some major policy change within its network that has a fairly serious impact on your own network. Okay, how do you go about solving these? Ooh, that means the wireless has gone down. Sorry. The next step is to try and go and fix the problem. And that's simply not about dividing the network, jumping into your network and trying some random commands. I mean, I've seen a lot of people, especially when you're operating more in the panic mode, you just simply dive into the network and do this and do that. Oh, I think it was this, and oh, I remember changing this yesterday, so I'll go and undo that. not a very good way of troubleshooting, especially when you don't really understand what the problem is. Yes, I know we're all trying to work really hard to minimize downtime, but actually sitting down and spending a bit of time figuring out what could be wrong, you actually, even though it may seem to give you a longer downtime in the first instance that you tried, actually you come to a faster resolution. I mean, I've been there, done that so many times. Panicking doesn't really solve the problem. And before you actually begin jumping into the network, well, as I've been saying, don't panic. Create a checklist. Create a list of things you want to actually try and check, and then work through that checklist. Try and start at the bottom and work upwards. Let's say if BGP has fallen over, well, there could be a whole range of things that was wrong. Try and figure out what could have caused it to fall over and look at all possibilities. I mean, it could be something as stupid as the circuit that the router is connecting to has gone down. Okay, it sort of reminds you of the old joke, my computer doesn't work, sir. Well, is the power switched on? It's that kind of that thing you've got to think of. Checking that the power is switched on isn't as stupid as it sounds. I mean, it can be the solution in quite a few problems. So, I'm not really going to mention checklists at the start of the presentation, but as we sort of get about halfway through and so on, I'm going to start making reference to the checklists, how you're going to actually work through any of the problems. And as I was saying before, it's what a lot of NOC staff actually follow when they're trying to diagnose and solve network problems. Okay, you've also got to be aware of the tools. If you've got one vendor in your network, you can probably figure out what all the tools are pretty easily. When you have different equipment, multi-vendor network, you have more tools that are available to you. Some equipment may have tools that others don't have. So you've got to try and understand these and be aware of what you can use with them to actually help you in what you're doing. Familiarize yourself with these tools. For example, is logging of the BGP process enabled? A lot of defaults don't have this. I mean, it is a default now in Cisco iOS. You get log messages pretty much anything that's happening in the BGP process. Are you storing these logs somewhere useful? If you're just storing the logs in the actual onboard on the router, you may have only got a small buffer, and you don't know what happened a day or two ago. So stick some of these logs somewhere useful so you can actually have a look at the history of what might have gone wrong. And do you know what the logs mean? When some of the logs can have a lot of gibberish in them, so try and understand what this gibberish could actually mean. Are you familiar with the BGP debug process? Some of the implementations allow you to debug the BGP process. Do you know all the commands available, or what is available, what you can do with them? Yes, the customer support will say, don't ever dare use them. But that's just so you don't go and switch on crazy things and then complain that it doesn't work, the router doesn't work right. But you can actually use some of these tools to very, very good effect. So check the vendor documentation, check operational recommendations. Okay, in other words, what your peers in the industry might say, any documents have been written by other service providers or other operators, and so forth, to get tips of what you can do. And then you can go switching on some of the debug tools. You want to work on the principle of having fewer surprises. So you should be surprised if you switch on full debugging on 130,000 prefix routing table that your router is going to probably fall over. Okay, so that's the fundamentals. Say that there's nothing really too specific to BGP. It's all fairly simple, straightforward troubleshooting that you would apply in any part of a network operation. So now we're going to really look at the main part. What sort of issues that you can have within your own network? I'm not going to include any configuration examples in this. I'm just going to have a look at some of the principles and some of the common problems and the solutions that you can get. So rather than load this down with iOS configuration examples, we'll just have a look at some of the actual concepts themselves. And I split it into 4 pieces. The first one about peer establishment. Many, many issues with peer establishment, and people look for the complicated reason why there are problems, and they generally tend not to be like that. Then we've got missing routes, inconsistent route selection, and of course loops and convergence, which is entertaining as well. Peer establishment. I like this slide because in these days people are very security minded and they put the filters in on the edge of the network like the good people they are, and they forget to allow BGP. So I usually have an email or two per month that says, well, I'm trying to bring BGP up, but, and because people will forget port 179. BGP uses TCP 179. So you need to allow that through your packet filters between you and your neighboring router. This is for establishing BGP peering between you and your neighboring AS. And that's definitely a frequently occurring problem. People are over-aggressive with the filtering. The second problem, IP connectivity. Can you actually get to your neighboring router? If you're trying to bring up, say, internal BGP with a router somewhere else in your network, well, you can specify the IP address of that neighboring router, but can you actually get to it? Can you trace to it? Can you ping it? Because if you can't trace or ping to it, there's not much chance of you actually going to bring up a BGP session either. Those two are very, very simple, but oh my gosh, I come across those so often. People don't do that fundamental check. So if you have a BGP session not coming up, first thing you check, filters, and can you actually reach the neighboring router at the address you specify. Once you've got that far, of course, the open messages are exchanged, peering addresses must match, and the local AS configuration must match. That's another classic. Trying to bring up an iBGP session and you've typoed the actual AS number. You've maybe thrown in an extra 0 or a 1, or you got nervous on the keyboard and maybe typed in an extra digit for the AS or something. Or you've confused an 8 with a 0 because it's hard to read what your colleagues scrawled down on a bit of paper. I've seen it all. It all happens. You need to make sure that these type of things match. Okay, so some of the common problems: no IP reachability, you've got incorrect configuration, flapping peers, another issue. There could be layer 2 problems. They're the most common. Link saturation problems or CPU utilization problems all give you flapping peers. So let's have a look at the peer establishment. You have a simple situation like this. Well, trying to bring up a session between router 1 and router 2. Are the two routers actually sitting in the same AS number? I mean, you can check that by looking at the configuration quite easily. Is the remote AS assigned correctly? So, for example, peering between router 2 and router 3, have you actually typed AS2 into router 2? Have you typed AS1 into router 3 for the neighboring AS? And you just verify with the diagram or the documentation that you have. These are very simple things to actually overlook, certainly with some of the AS numbers. I suppose I tend to find in the days when AS numbers were like 2 or 3 digits, it was harder to go wrong. But now in the 30,000 or so, it's very easy for people to transpose numbers. I mean, when you're typing or when you're tired, it's so incredibly easy to transpose numbers. And there's so many issues simply caused by that. So if you're finding trouble when you're deploying BGP in your network, trying to bring up the BGP session, check things like that. Have you actually entered the configuration properly? So we assume that IP connectivity has been checked, that you can reach the neighbor. Check TCP to find out what connections you're accepting. On most routers I know of, you can actually show what TCP connections have been terminated on the box. Do they make sense? Do they match what you expect? Do the source and destination addresses match? One common problem that you find deploying iBGP, when you deploy iBGP, you run iBGP between loopback interfaces on the router. You don't run iBGP between the physical interfaces. Right, you should know that. If you run it between a physical interface, that physical interface goes down, your iBGP goes down. The whole point of deploying iBGP in the network is to have a stable system of delivering prefixes around within the backbone. So having an internal BGP dependent on a physical interface means that your internal BGP is only as stable as the interface or the network that interface is connected to. Most routers have at least one interface connected somewhere. In fact, any router in the core of the network will have multiple. So a physical circuit failure or interface failure can be worked around by running the iBGP between the loopbacks. So a common problem is you're running iBGP between the loopback, but you've somehow missed out some of the loopback configuration. Now, I mean, you may be lucky, the iBGP may come up. You may be very unlucky, as is more often the case, and the iBGP just sticks there. You look at it, it looks fine, and you forget to tell the router the basic thing of saying, we're actually peering between the loopback interfaces and not between anywhere else. Remember, the source address for any outgoing packet is the outbound interface. So it's the IP address on the outbound interface. Outbound interface is not the loopback. It could be your serial, it could be the Ethernet. So it's important to tell BGP, my outbound source is actually the loopback. Now, eBGP is by and large problem-free when you try and bring up a peering. You only need a one-line configuration. Say the neighbor is this address, that AS number. But, yes, the source address is that of the outbound interface. Sorry. Destination address is that of the remote router. That's easy too. It's directly connected. Time to live is set to 1. There's no real problem with bringing up BGP. You've got your filters right, so you're allowing TCP 179 in both directions. But the problems start arising in eBGP when you try and do load balancing, or you try and use eBGP multi-hop. In other words, you're setting the time to live to be more than 1. You're trying to talk external BGP with a device that's not directly connected to the local router. Okay. For example, you may be trying to peer iBGP with a router, central router in your neighboring ISP's network, rather than on the aggregation router. Some ISPs do that. A lot of ISPs won't. A lot of them have policies where they will not let you do eBGP multi-hop because the problems you end up with are so obscure that they could look as though there's something else. Okay? Load balancing can be the other issue as well. If you're aware how you do load balancing, you point a static route to the remote loopbacks of the remote router, and then you can peer eBGP with that loopback. And that's great for load balancing over parallel circuits. But you have to be kind of careful with that as well, because the eBGP session might stay up, or the link might be very, very bad, and you may not be aware that it's actually a physical connection between your router that's causing you some of the problems. So you've got to be kind of careful. And in fact, a lot of my trainings, when I'm introducing people to BGP, I just say, don't even think of using the eBGP multi-hop unless you really understand what's going on and your neighbor knows what's going on and you're aware of the potential problems. Okay. So the eBGP multi-hop problems, there can be IP connectivity to the remote address. So is the route in the local routing table? Is the route in the remote routing table to get back to you? Because you may have everything set up right, but does your neighboring ISP have everything set right as well to point back to you? In fact, that's quite a common problem. They forget to put their static route pointing back to your loopback. You can check this using ping. Okay? You can check it using ping to the remote address you're trying to get at. You can specify your source address, whether it's outbound interface or your loopback or whatever. And that will tell you pretty clearly what the problem might be there. Other filters in the path. I mean, eBGP multi-hop between you and your immediate neighboring ISP shouldn't be too much of an issue. But if you're crossing multiple network boundaries, somebody could be filtering BGP somewhere in the path. And then you've got to cooperate and work with the ISPs in the path to try and make this thing work properly. Passwords. I mean, I know a lot of ISPs don't use passwords on their iBGP and eBGP session. It's certainly a good current practice for a lot of people that I know. People using passwords on BGP sessions introduces its own set of problems. You type the password in on the local router, the remote router, you find the BGP session won't come up. You've been through all the previous troubleshooting and it just won't work. Some of the common problems I've seen are missing passwords. I mean, you actually just forget to type it in. Cut and paste errors. Okay, so it could be white space, or a character might have snuck in, or a character might have been missed out. Cut and paste is just such a nasty thing, certainly when it comes to running a network, trying to troubleshoot what's going on in a network, because it introduces so many possible problems. Typos as well. Certainly if you're using quite an obscure password, trying to distinguish vertical bars and backslashes and commas and full stops, and the number 0 with the letter O, all those things I've seen cause problems. Capitalization. Sometimes capitals, there's case sensitivities or non-case sensitivities. Extra characters, white space. If you're using white space in a password, well, how many white spaces are there? And so forth. So when you're dealing with passwords and BGP sessions, you need to be actually quite careful. Common solutions, actually, well, quite simple. You start again. It's just too hard to try and troubleshoot what the password problems could be. Some implementations will encrypt the password as it's stored on the router. So you've got no way of knowing what you've typed in any case. So it's much easier just to say, okay, start again. Type the password in, and does that bring the session up? Don't cut and paste. Flapping peer. I mean, the symptom you have is that the eBGP session flaps. It comes up, stays up for a bit, then falls over. And then it restarts, comes up, falls over, and so forth, round and round and round. Well, you need to ensure that logging is enabled. If you don't have any logs of what's going on in the router at either end, you have no clues what's going on. And you should always be trying to configure your router so that you get maximum clues to try and help with the troubleshooting. What do the logs say? Well, a problem like this is usually caused by the BGP keep alive getting lost. A keep alive is sent every 60 seconds or whatever the two routers negotiate between each other. And if a keep alive gets lost, then the BGP session is pulled over. Okay? No keep alive, it means the local router assumes the remote has vanished, so it tears the BGP session down. Because, you know, BGP is trying to do its good thing of peering gone down, I want to fail over to my alternative path. And so it will try and tear the session down as expeditiously as it can. Of course, it then tries to reestablish the session, as it tries to do. And it managed to bring up the session, everything happy, then it starts exchanging updates, and everything freezes up again. Well, the keep alives can get lost because they get stuck in the router's queue behind the BGP update packets. Now, the BGP update packets tend to be packed into the full size of the MTU that's available, so 1500 bytes, for example. So all the updates are packed in there, so you're efficient with the number of packets you're sending. Whereas the keep alives are probably occupying nice little packets like that. So you can send the keep alives because they're little packets, but the updates are big 1500 byte packets, and they get stuck somewhere. There's something in the network that's not allowing these through. So if you see something like this, it's worth using ping with different sizes to try and find out where the jam is. Now, it could well be that ICMP gets through it and doesn't have a problem, and TCP does, so you've got to try and use a TCP-based ping. But generally, an ICMP ping will let you see if there are any MTU problems within the network. And of course, then, if you find that that's a problem, you need to pass this to the people who look after the layer 2 part of your network. But try and be helpful. I mean, not just say, can't get BGP going, MTU problem, dump. I mean, try and figure out where the problem might be in the network. If it's not between immediate neighbors, or you've got some other physical bits in the network, you can try and use ping to find out where the problem might be. You kind of have to work together. Each troubleshooting team is not a particular island. They tend to all sit in the same place in any case, so working together makes a lot more sense. Other common problems. Well, if you see a BGP peering cycling within about 3 to 5 minutes, it could be the remote router rebooting. Right? It's come up, It's working, and then it suddenly crashes, it comes up again, and so forth. That tends to be a 3 to 5 minute cycle. It might even be longer, depending on the well, I suppose the loading of the neighboring router. But that's a sort of slower BGP cycle time. Or it could be the remote router BGP process is unstable, and that's just restarting. And that's possible too. Another favorite, traffic shaping and rate limiting. People will rate limit different sizes of packets. So they may let little packets through and may do horrendous rate limiting on big packets. And that's going to affect BGP updates. You might be able to bring the session up, but it could be taking hours and hours and hours to establish your 130,000 prefix feed from your neighbor. What rate limiting are they doing? What traffic shaping are they doing? MTUs incorrectly set on links. So make sure that path MTU discovery is actually switched on. I'm not sure what all the routers do, but in Cisco IOS it's disabled by default, so you need to enable that. Let's see what else. Well, if you're not using ATM or frame relay links, well, I don't know if there are a great deal of ATM or frame relay links still in use, certainly here in North America, but parts of the world I visit, they're used quite a lot, and there still can be issues there, as we know with MTU. But if you're not using those links, well, there could be issues such as faulty muxes, bad connectors, interoperability problems, PPP problems, satellite, radio, weather, and so on. I mean, certainly on poor links, you can get small packets through very easily, but the large ones that are needed by BGP update probably won't survive. So there could be issues like that too. Trying to send packets through fog or snowstorms or heavy rain and that type of thing. But ping is the type of tool that's best suited to troubleshooting this. Okay, so that's peer establishment. What I've described covers most of the peer establishment problems that I've come across. Most of them are some of those. What about missing routes? Well, once this session has been established, updates are exchanged. So updates contain all the routing information that's passed from BGP speaker to speaker. The router will pass all the locally known routes, and basically it will only advertise its best path. Right? It will advertise the best path. Once we've sent everything we know about, we don't only pass on the updates. Okay, so after the initial flood of 130,000 prefixes or whatever, you then only send updates onwards to your neighbors. Best path is received from eBGP peer, and you advertise that to all peers, so whether they're external or internal. If a best path is received from an internal BGP speaker, that's only advertised to external speakers. Remember, you need a full iBGP mesh. You don't get an iBGP speaker passing a prefix to another iBGP speaker, unless, of course, you're using route reflectors. But I'm going to assume for this that we're not using a route reflector, and we're not talking about BGP confederations either. Okay, so let's look at these four. First one, originating a route. Common problem occurs when putting prefixes into the BGP table. Now, routers will run different routing processes on them. BGP is just one of them. Right? You've got OSPF or ISIS, static routes, and all the rest. All these are used to feed the routing table, or RIB. And then the routing table is used to build the forwarding table, or the FIB. Okay? So, BGP table is just one of the tables, and it's the best of all those is what's used to go into the routing table. To put a prefix into BGP, you generally have to make sure the prefix exists in another routing process as well, whether it's a static route or OSPF or so forth. Typically, most people do it by having a static route pointing to customer. That way you put customer routes into your iBGP. For prefixes you want to announce to the internet at large, it's a static route pointing to a null interface or any other type interface that will act as a pull-up. It will let you generate your aggregate and announce it to the internet. Generally, the BGP process will require that the prefix sits in the routing table before it will be announced or put into the BGP table. That's quite a common one to forget. And again, most of my experience is with Cisco boxes. And people will put the network statement in for BGP, completely forgetting that they need the equivalent entry in the routing table, whether it's a static route pointing to the customer or a static route pointing to the null to generate the aggregate. Both, well, one or the two is essential. What about the update exchange, missing routes? Well, I never really saw too many problems until route reflectors came on the scene. It's such a nice solution to help scale BGP, but people seem to enjoy breaking all the rules all the time. I mean, whether it's through bad documentation or just, I don't know, trying to take shortcuts or believing that route reflectors meant that there are no more rules at all with an iBGP. But there seem to be so many issues with route reflectors that people run into. Common issues are, well, there are two of them. There's the clashing router ID and the clashing cluster ID. Here's one example. We've got two route reflector clusters. Router 1 and 3 on the first one, router 2 and 4 on the second one. Router 1 is the route reflector, and router 2 is the route reflector, respectively, for the two clusters. Router 4 is advertising a prefix. I've said network 7/8 here. Router 2 has the route, but 1 and 3 do not. And that causes lots of head scratching because people don't understand why. I mean, we've set it all up according to the manual, and it's all just wonderful. R1 is not accepting the route when R2 sends it onwards, and the reason is usually something like the clashing router ID. If R1 sees its own router ID in the originator attribute and any received prefix, it will reject that prefix. If my router ID is there, that means I've sent the prefix out somewhere and it's coming back to me. So I don't want to hear it again, because I know it's mine. Okay? And that's one of the ways a route reflector attempts to avoid a routing loop. And of course, all you've done is you've set up a router ID in the route reflector, and then another route reflector cluster, you set the same router ID by typo, deliberate or otherwise. Most usually by typo. Okay? Some people come up with wonderful strategies to set up, have unique router ID type things across the whole network. And I never honestly see the point in doing that. All routers will generate the router ID automatically. Okay, they'll get it from somewhere. It's a unique IP address. IP addresses are unique. So it could be from the loopback if you're using a loopback address per router, or it could be from one of the physical interfaces. That's an IP address. That IP address will be unique. So trying to set a router ID by hand, I don't really see a great deal of sense in that. And most of the problems I've seen in this case come from where people will set the router ID by hand. And people who don't set it by hand, they just leave the box to do its own thing, generally don't have this problem. What about this one route reflector cluster? You've got two route reflectors. R1 and R2 are the route reflector for the cluster. 3 and 4 are the clients. R4 is doing the advertising. R1 and 3 do not see the prefix. Well, same thing. R1 is not accepting the route when R2 sends it on. But this time, R1 will see its own router ID and the cluster ID. So we've got clashing cluster ID. If you set the cluster ID the same on two route reflectors in the same cluster, then each route reflector assumes that you're running a full mesh from the clients. So each client will peer with each route reflector. But of course, if I just move back, what people tend to do is just say, set up client peerings with the route reflector that's closest, and they end up with black holes in the network. The situation where a prefix that comes from one route reflector goes to this one passes on here, this one assumes that he's got a peering with R4, so he doesn't need to hear the prefix coming from R2. Okay? That's a very common problem. People trying to set up route reflectors this way. Because some of the original documentation way back said that the way you get route reflector redundancy is to put two route reflectors in the same cluster. And a lot of people have done that quite successfully, but then they've been meticulous about making sure that each client peers with each reflector in the cluster. And, well, I've never done that, even from the day that route reflectors first appeared. The way I did it was overlaid my route reflectors. I had 2 clusters overlaid. 1 route reflector per cluster, 2 clusters per part of network. And we never ever had any problem like this at all. And this problem only really happens when people forget to do the full mesh and have dual redundant route reflectors in the cluster. So just don't do the dual redundancy like this. Do it by the overlay, and you just won't have this problem. Okay, filtering. You get all sorts of types of filters on routers, especially for BGP. You can filter by prefix. You can filter by AS path. You can filter based on community also. You can also manipulate attributes and apply policies and so forth. You can apply this in inbound and outbound. And these give all your own class of problems also. If you suspect a filtering problem, it's good to become familiar with the router tools to find out what filters have been applied and how. Hot tip, don't use cut and paste. I know cut and paste is nice and easy and all the rest, but really, it causes so many problems. In fact, I've seen more problems caused cutting and pasting trying to diagnose filters than anywhere else. Okay? You can have weird effects from cut and paste buffers. What is in the cut and paste buffer may not be what you put in there. You could have problems on the client, on the router, or even on the connection. Packets get lost. If you're trying to cut a whole big configuration and paste it over a lossy link, well, you might lose bits of it. Who knows? I mean, that has happened. And that could do weird things to the router. It's generally much better to prepare your configuration and load it into the router by some other method. TFTP, FTP, whatever. Typos and regular expressions. That's one of the common problems. Extra characters, missing characters, white space. Extra characters is quite common. Or getting a minus in place of a plus, or a square bracket in places of a curved bracket, or whatever. Regular expressions need to be fairly precise for doing filtering. So if you get them wrong, it can do really, really weird stuff. And if you see strange things happening with your BGP filtering with your neighbor, you're not getting any prefixes, you're getting too many prefixes, it's worth checking your inbound filters or your outbound filters really, really carefully. Okay? You also get typos and prefix filters. Watch the command line interface on the router. Watch the filter logic if you need to watch the filter logic. It may not be as obvious as you think, and may not be as simple as the manual says. And this is my favorite. Watch the net mask confusion and the 255s. Right, okay, these days, most people are using mask notation for doing prefixes. You're doing blah-de-blah-de-blah /24. But if you're still using some of the old notation, it could be 255.255.255.0. And when you're typing that, it can be easy to mix up 255 and 0. Yes, I know they sound very different, but you'll be amazed how many problems are caused by people mixing up 0 and 255. Right, a /24 net mask, I've seen it quite often as 255.255.0.0. Or even better still, 255.225.0.0. I don't know why, but those just seem to be so common, even though these seem to be very strange things to put together. People mix those up all the time, and they cause so many problems. Avoid them by using the slash notation, the mask notation. You generally can make less errors doing that. I mean, you can still make mistakes, but a lot less. Communities. A lot of ISPs are using communities. But it seems to be each implementation has different defaults for when communities are sent. Some don't send communities between peers at all. Cisco. Others do for iBGP and not for eBGP. Sensible. Others do for all BGP peers by default. You need to understand and watch how your implementation actually handles communities, especially if you're mixing different brands of router in your network. You need to make sure they all do the same thing. Decide what your default should be and then go from there. Don't just say switch on, basic configuration, off we go. Right? It just makes troubleshooting harder. So you need to try and understand what the implicit filtering rules are before you try and work out how to solve the problems. More on communities. Each ISP has different policies. Never assume that because communities exist that your peers will actually use them. Okay? Often peers will advertise that they support the RFC 1998 style communities. If you've seen any of my other BGP tutorials, I talk at great length about how ISPs around the world will use communities. Just because they say they do, it's worth checking. If you sit down and try and figure out why you're sending them 5 or 6 different communities to get them to send you a certain group of prefixes, and you're not getting them, well, there could be a reason for that. It's worth asking them first if they're actually obeying them, and checking that they actually are obeying them. Don't just assume. It'll save you a lot of time in your troubleshooting. Also, never assume that your peers will pay attention to the communities you send. I've called it the no export problem. Just because you send a prefix with no export community set does not mean that your neighbor will obey it. I mean, he may have set something that says ignore all communities. And so if you send something with a no export to your neighbor and he's saying ignore it, he's going to send that prefix everywhere. Okay? So it's cooperation, not assumption. How do these all fit into a troubleshooting? Well, this is about trying to send prefixes to your neighbors. Now, it could be neighbor within your own network if you use communities for filtering within your own backbone. Some ISPs do this. They may carry full prefixes in the core and maybe just their own prefixes on the edge. And they use communities to do that filtering. I mean, we certainly did when we were at UUNet. Okay, so when you're trying to troubleshoot why prefixes aren't going places or are going places when they shouldn't be, check your communities. Make sure that the defaults that you've set on your router are actually there or are still there. I mean, I've seen, well, certainly from a Cisco point of view, the send community directive disappear from configurations magically. And no, I didn't touch the router. But somebody's logged in and done something by mistake and they've forgotten all the commands as they backed out of it. The magic send community they've forgotten, so your community is not sent to your neighbor, so your neighbor cannot apply any policy at all what you were hoping to do. Okay. So what you want to do is try and make and then stay with some simple policy rules. Okay, most implementation of particular rules for filtering prefixes, AS paths, and manipulating BGP attributes. And yes, they can get really complex situations. In an iOS, route maps can be very, very complex, certainly with some of the newer features that have been added in there. You can tie yourself in knots very, very easily. I've seen people do that on other implementations too. It's very, very powerful policy language. And if you're using a policy language to apply policy as well as doing filtering, you can get some really amazing things happen. So when you're designing your policy that you've set up, try and set up simple rules and stick to those. Okay, iBGP mesh problems. Well, here's one example. Customer complains about patchy internet access. He can reach some parts of the internet, but not others. Okay, he can get to some of your backbone, but not all of your backbone. He can get to some of the internet, but not all of the internet. When you see things like that, I mean, if he's complaining about poor performance, that's nothing to do with BGP, usually. But he's complaining about, oh, he can get to half of Europe, and he can only see your West Coast operation and nothing in the East. You should try and start suspecting iBGP problems. I mean, if you see nothing wrong with your network otherwise, try and suspect an iBGP problem. It's more than likely to be that. In this case here, the customer is connected to R1. Okay, customer connected to R1 up here. He can see AS3, but he can't see AS2. He also complains about not being able to see sites connected to R5. So you can see bits of your backbone, most of your backbone, but not all of it. And of course, typically you get no complaints from other customers, because this is your really fussy customer who measures connectivity to your entire backbone every 30 seconds and sends you emails when it breaks. And if everybody else is like, no, yeah, internet's broken again, they go away and make a coffee. But, so, okay, no complaints from other customers, just this one. This is like 90% of the time, this is an iBGP problem, certainly in my own experience. Okay? The full mesh isn't complete. That's the problem. if you look at it, customer's connected to R1. If you can't see AS2, well, AS2 is connected to router 3. Well, that means router 3 is somehow not passing routing information about AS2 to router 1. So think about it. The customer connected to router 1, he can't see AS2, so he's got no routing information that gets him through to AS2. He has no idea how to get to network 10.10/24. Okay, so there's a problem running between router 3 and router 1. You also can't see R5, or customers connected to R5. So R5 is somehow not passing routing information about sites connected to R5. But he can see the rest of the internet. So the iBGP is working everywhere else. So it's not that his prefix isn't being injected into the iBGP properly. That's not the problem. It's not where he's connected to, it's how his router's connecting to, or the router he connects to is connecting within your own backbone. So when you're using a full mesh iBGP, check on every iBGP speaker that it has a neighbor relationship. If you've got 10 routers in your network, you'll have 9 iBGP neighbors. 100 routers, you'll have 99. Okay, when you start to get to the extent of 100 routers, 99 iBGP neighbors, that's a lot of counting that you have to try and do. But the point is, when you have a large number, it's easy to miss one. Especially if you just have got a random numbering scheme for all your neighbors. If you're using loopback, iBGP peering between loopbacks, you number them all sequentially, you can usually spot when one's missing. And it's very easy, you just count from 1 through to 100. And if anything apart from your local router is missing, then you know you've got a problem. Okay, so an example here, what was wrong was the peering with R3's peering with R1 was actually down. Okay, it was listed as down. Through some kind of misconfiguration. And you can go back to the early troubleshooting that I did at the start to show you what that misconfiguration could be. And of course, router vendors have quite kindly given you configuration shorthand to make it easy. For example, in iOS, you've got peer groups or peer templates. And that it gives you shorthand. And it's like, yeah, that makes things work a lot faster. But you can also get mistakes with those as well. When you're talking about setting up iBGP, some people do core iBGP and then an aggregation edge iBGP. So you've got maybe 2 different peer groups. And of course, you could apply the wrong peer group to the wrong neighbor. And you may even use peer groups for your external BGP. And you may call one eBGP peer, another one iBGP peer, and you may typo the names, so you actually end up using the wrong peer group and get a completely different result from what you're expecting. So I say, the more shorthand it is there, again, you've got the potential for different mistakes happening. So when you're setting up your iBGP mesh, it's worth checking very, very carefully that all the peerings are up, that you're using the correct names for the peer groups, and so forth. Okay? So, as I say, use configuration shorthand for efficiency, and it helps you avoid making policy errors within the iBGP mesh. Certainly for a large number of peers, it's a tidier configuration if you can use any shorthand. But of course, be careful that you don't introduce typos in these subroutines themselves. This is why people tend to use route reflectors these days. Rather than driving a huge iBGP mesh, we start splitting our network up into lots of route reflector clusters, and that helps with trying to keep the number of iBGP peers on each router down to minimum. But then, of course, stick to the route reflector rules. Keep them all nice and simple. Don't go for complex setups and situations. As I say here, changing defaults and ignoring the best current practice techniques just introduces complexity. And I think it's been said here for years and years, keep it simple. Right? If you try and keep everything as simple as possible, it makes your troubleshooting much, much easier. So these are some of the common situations that you can get with missing routes. Okay, inconsistent route selection, or the router's got it wrong, honest. Well, there are 2 common problems with route selections. Inconsistency, in other words, the router makes gives a different best path every time, or it just makes a mistake. I mean, you're determined, the router's got it wrong. Well, RFC 1771 is still the standard, the BGP standard. I mean, the new RFC is like oh so close to actually appearing. It was in draft 21 or somewhere now. But the thing is, decision algorithm kind of appeared before BGP was really used to the extent that it's being used today. I mean, that's a stupid comment, but obviously the standard has to start somewhere. But we've gained a lot of operational experience since it first appeared. And of course, every vendor has taken all this experience they've got from the customers and tweaked the algorithm. And all these tweaks can lead to interesting interoperabilities and so forth, because each tweak is slightly different. For example, the RFC says that the MED is not always compared. And as a result, the ordering of the paths can affect the decision process. For example, the default in iOS is to compare the prefixes in order of arrival. Well, the RFC didn't say anything else, so, well, what do? So we just compare them in the order of arrival. The most recent to the oldest. And of course, this will result in inconsistent path selection. If you reset a BGP peering, then the prefixes that arrive from the reset peering become the newest, and then your best path may change. Well, it pretty much will change. And so certainly if ISPs have got large numbers of connections between them, they'll see the best exit point go, the best exit go from here, to there, back to here, depending on where they did their maintenance, which is highly annoying. Of course, the symptom is that the best path changes every time. And no, it's not a bug. It's just, well, that's what the implementation does. And yes, it can cause problems, routing loops, convergence loops, changes in traffic patterns. The latter is probably the most annoying one for people. And if you've never seen this before, I mean, you just have sleepless nights and days and nights and even more days trying to figure out what it is. But in this case, the vendors provided a simple workaround because enough people complained about it that the deterministic MED configuration was added in there. And so what happens now is the router will give you the same answer every time. It doesn't do the age comparison. It does the comparison based on AS number. So smallest AS number all the way up to the largest is how the comparison is now done. So for example, in this picture, router A's got 3 paths to get to AS10. Okay, the MEDs from AS3 are not compared with the MEDs from AS1. You only compare MED if it's from the same AS. Of course, there's a hack to work around that if you don't like that either. Router A will sometimes select the path from router 1 as the best, but may also select the path from router 3 as the best, depending on when you reset the session. So you have got the best path oscillating back and forth between router 3 and router 1, which is not good. And if you've got expensive links connecting your AS2 to AS3 and 1, you've got this traffic slewing back and forth depending when you do your maintenance. Very unpleasant. So if you enable the knob that was provided, the deterministic MED one, then the paths are ordered by neighboring AS, and then the best path is the same every time. It's worked on per neighbor AS group. And no matter when you do your resets or how often do your resets or your maintenance on your edge routers, you'll always get the same best path selection result. Okay. I mentioned this one quite a bit because it has been quite a common problem, that, well, something that I've come across. And it's sort of one of the reasons why the fixes provided to the best path selection, or maybe knobs provided to the best path selection, that may make a lot of sense for your network. Again, part of the troubleshooting here is, well, if you do this, then you don't have to troubleshoot this problem. But if you see this problem, this is the particular solution to it. Okay? And then, yes, just the diagram, what the solution is. And this time, with that knob applied, AS1 path is always the one that is chosen, because of the ordered according to AS numbers. So AS1 will beat the 2 AS3 best paths. Okay, second example. Best path changes every time the peering is reset. Well, again, there's something else not specified in the RFC. By default, the oldest external is the best path. Okay, that's just what's there in iOS. I mean, if the oldest path is the best one, well, that's stability. I mean, the oldest one has been there for ages and ages and ages. whereas a new one's flapping up and down. Well, you don't particularly want to have your traffic slewing to the new one and then back to the old and so forth. Okay? But again, this can be annoying too. So you can disable this by enforcing it to conform to what the RFC actually stipulates, in other words, comparing the router ID. But it's just difficult. I mean, people have asked for particular enhancements that go counter to what's been written down, but then other people wanted to work according to the RFC, depending on their own particular situation. It just depends on how networks are configured, how the external relationships are. So this could be another potential problem where you see the best path changing every time a peering is reset. If that's an issue for you, then it might be this particular thing that's causing the problem. The third one is only peculiar to my dear employer. Path 1 is higher local preference, but path 2 is better, always. Because iOS has synchronization on by default. I mean, synchronization is an ancient historical thing that's still there by default, unfortunately. And basically, if a prefix is not synchronized, in other words, it doesn't appear in the IGP as well as in BGP, it's not going to be considered for the best path process. This is like the 101 that catches out everybody who tries to deploy BGP on a Cisco router but doesn't read the documentation. Okay, they forget the no synchronization command is necessary. Phone Cisco tech, have you done the no synchronization? Oh, I didn't know how to do that. I mean, it doesn't say anywhere that you've got to do that. Okay? Historical default that's still on, that's there to catch everybody out. And what's happened is synchronization is part of the best path process. If you don't disable it, then it will be included. The prefix has got to appear in your IGP as well as the BGP, and the router will appear as though it's making the wrong decision, because the synchronization test is done before the local preference check. Okay? So, just a summary of that. RFC isn't perfect when it comes to path selection. You probably know that just from operational experience, but that's fine. We shouldn't be surprised. Vendors and ISPs have worked to put in stability enhancements. Vendors are generally asked to or pushed into doing these enhancements, or knobs, whatever you want to call them. But these can lead to interesting problems too. And of course, some defaults linger on much, much longer than they have any right to do so. So again, watch the defaults that your box actually comes configured with, because they can cause issues also. Finally, loops and convergence issues. One of the most common problems. Every minute, routes flap in the routing table from one hop to the next one. With full routes, the most obvious symptom is just a high CPU in the BGP process. And typically it's something like this. Router 3 will prefer routes for AS4 1 minute, and then a minute later, router 3 prefers routes for AS12, and then back to AS4, and it oscillates between the two different exit points on a pretty much 1 minute basis. What's going on? Well, this symptom is almost always caused by the BGP next hop being known only by BGP. And one of the rules is that the BGP next hop must be known by another way. It cannot be known by BGP. Okay? It's a common problem. I mean, when this first hit me about, I think it was 7 years ago, I first came across this one. I mean, it took me about 2 days to figure out what was actually going on. And I wasn't actually aware that was what it was. It was just a bizarre problem of traffic oscillating between our two exit points in London. It didn't bother me too much, but it's the 80% CPU in the router that was causing a bit of problems, and customers were complaining about big round trip times. So we had to try and figure out what it was, and it was simply because the next hop was only known by BGP, because somebody had removed a static route. And it was, well, somebody had removed a static route. And it was as simple as that. Okay? So the BGP next hop was known via BGP, which is an illegal recursive lookup. And what's happening was the scanner will notice that the BGP next hop is known only by BGP, so it'll drop that path. So your alternative path is known via the IGP, so it will install that. But then, of course, your next hop, which was known in BGP, is then valid, So then it will be reinstalled as the best next exit point. So you just oscillate back and forth between these two. Okay? And it just goes on forever. And the reason it's 1 minute, because in Cisco IOS the scanner runs every 1 minute. So that's why you have this 1 minute cycle time. So if you see this 1 minute cycle time using Cisco boxes in your network, it's going to be this, more than likely. So make sure that all the BGP next hops are known by the IGP, whether it's OSPF or ISIS, or static or connected routes. The next hop is also an iBGP. Ensure the iBGP distance is longer than the IGP distance. That catches a lot of people out. I mean, when the iBGP distance is set much, much smaller than, say, OSPF or ISIS, you can end up with this problem, because iBGP becomes more important than the IGP, which, quite frankly, it should never be. Or don't carry external next hops in your network. Use next hop self concept. In other words, you change the next hop for externally learned prefixes to the router itself. Right? So you don't have to carry your neighbor's IP address in your backbone, because he may be sending you the point-to-point link by BGP as well, or an aggregate of the point-to-point link. And that can cause weird stuff to happen. And that's what actually bit us, because our peer was sending us the network that was the eBGP next hop by BGP. Of course, when the person who was doing the tidy up of the network configuration saw that we already heard this prefix by BGP, said, well, why did Philip put the static route in there? So he took it out. And, well, of course, the configuration was like, yay, huge. And did I spot that all that static, one static out of like 60 or 70 other statics in the box were missing? No. So I didn't do that. And of course, what I should have done, which I finally did about 36 hours later, was look back through the RCS log that we kept of the configuration. And I was like, static route was missing. That's what it was. Put it back in, and this oscillation disappeared. But this is generally the best solution. Don't carry the external next hops within your own network. Okay, so that's the general summary. High CPU utilization in the BGP process, usually a convergence problem. Find a prefix that is changing a lot. If you can do a show on that particular prefix, and if it's changing a lot, like last update was within a minute or two, try and troubleshoot or do debugging on that particular prefix. Find out what it's doing, what's happening to it. Okay, got a BGP routing loop. First check for IGP routing loops to the BGP next hops. BGP loops tend to be caused by, well, not following the physical topology in route reflectors environments. Some people love to have route reflectors, just like one route reflector in their whole network of 500 routers. That's, well, yeah, okay, that maybe works some of the time, but then you end up with a route reflector definitely not connected to any of its clients by a physical point-to-point link, and that can end up with lots of trouble. And it can be caused by using BGP multipath within confederations. I haven't seen that so much. Lack of a full iBGP mesh is a classic for causing routing loops. And then to try and troubleshoot some of this, have a look at the routing table entry. Remember, the routing table is not the same as the BGP table. Look at the BGP table entry. Check the route to the next hop. Is it known by BGP? Is it known by IGP? Does it exist? And then finally in this section, convergence problems. Here's the first example. You've got a route reflector with 250 clients. It's not unreasonable. 100,000 prefixes, and just BGP will not converge at all. Logs show that the neighbor hold times have expired. Okay, the BGP router summary will show that peers will establish, drop, re-establish, timeout, and so forth. And it's not the MTU problem we saw earlier. Okay, this is another manifestation of this problem. And here we're either missing hellos or the peers are not sending them. We're missing the keep alive, or we're missing some information like that. And here you don't blame BGP. You look further down. Check for interface input drops. For example, if the number is a large number, you've got a huge number of drops in the interface, and the interface counters are showing recent history, then this could be the cause of the peers going down. You've got a large number of drops, large number of packets are being dropped on the router. And this could be due to the input queue being too small. And each interface will have some buffer associated with it. And if the buffer's not big enough, for example, you've got 250 peers there. 250 peers send the hellos all at the same time. You've got 250 conversations with the local router that you've got to try and handle. If your buffer can only take, say, 75 conversations, then what happens to the other 140 or so? Okay? They get lost. Right. Whoops. So, yeah, sorry, I missed the solution. The solution is basically to increase the size of the input queue so that you can handle all the communications that you have with your actual peers. Okay? Just make it a big number, much, much bigger than the number of peers that you have, especially if you're trying to deploy route reflector type networks like this. The defaults are too small. Second example, BGP converges in 25 minutes for 250 peers and 100,000 routes. We know it's not using a Motorola processor anymore. It's something that should be nice and fast from the modern day. So rather than just say, oh, well, it's slow hardware, try and actually figure out what's going on within the TCP process and check the MSS size. Enable path MTU discovery on the router if it's not on by default. Okay, that's quite important. Default MTU, certainly in Cisco's, is, well, MSS is 536, which means that the router needs to send almost 3 times the amount of packets compared with an MSS of 1460, which is what could be possible over an Ethernet connection. And if you do that, you'll amazingly find that you'll see BGP converging about half the time. 10 minutes or so is pretty good for 250 peers and a full routing table for each peer. Okay? So that's some of the possible problems you could find in some of the workarounds. I suppose it's less troubleshooting than saying, well, here's a possible problem that you can get, and here's the actual solution to deal with it. Right, in the final 15 minutes, I'm just going to have a quick look at some of the internet reachability problems. This is less of the local network and more how you go about troubleshooting problems between your network and other networks on the internet. I mean, that's quite an important part of troubleshooting also. Well, the first one is the BGP attribute confusion. People come to these BGP tutorials at Nanog and we tell them all about local preference and MEDs and AS path prepend. And then they go away. I do lots of workshops, I do lots of other trainings, and the amazing thing is people completely confuse what the different attributes are actually used for. If you want to control how traffic flows into your network, you need to send MEDs and AS path prepends or whatever to your neighbor. Quite often I see people try and use MEDs and AS path prepend just how to control traffic going out of the network. And I'm not completely clear how that's meant to work. Right? Routing information flows in the opposite direction of traffic. Very, very important fundamental concept. Now, I tell people in all walks of life about this, and I sometimes feel as though I'm insulting people by telling them this sort of thing. But I've seen seasoned engineers completely forget that basic rule. Routing information goes that way, traffic will flow in the opposite direction. Very, very important to remember that. If you remember that for trying to do troubleshooting, then it actually makes troubleshooting of multi-homing and transit and so forth so much easier. Right? As I've said in many words here, multi-homing and transit troubleshooting is often hampered because the relationship between routing information flow and traffic flow is forgotten. Right? I'm laboring the point because people forget this far too often. Path selection process I've kind of talked about before. Each vendor has tweaked the path selection process. You really got to learn what it is for your equipment. If you're using multi-vendor, try and make it reasonably consistent amongst all the routers you use. MED confusion. Default MED on Cisco IOS is 0. In other words, if you don't specify any MED at all, it is 0. It may not be this on your own router, okay, or your peer. Your peer may assume an MED of 2 to the power 32 minus 1 as the default. In other words, huge, very unimportant, whereas MED of 0 is very important. So you can end up with pretty interesting routing loops if you just leave default MEDs, where one default is 0 and the other one's 2 to the 32 minus 1. Community confusion. If you set community, it does just that. It will set the community to something. It overwrites anything else that's set on the prefix. So certainly in iOS, you can use an additive keyword to add communities to those that you've learned. Figure out what you want to do for your own equipment also. Use the internet format for community. In other words, AS number colon community number, rather than the 32-bit IETF format. The internet format is kind of easier to read, understand. Humans are not too hot when it comes to looking at 32-bit numbers, whereas two 16-bit numbers are kind of easier to handle. Cisco iOS never sends community by default. Others do. Okay? Figure out what it is. Never assume that your neighbor is going to obey your no export. He may overwrite any community you send. So if you're going to use no export, make sure your neighbor knows that you're going to use no export. AS path prepends. 20 prepends won't lessen the priority of your path any more than 10 prepends will. But there are lots of people out there who seem to think doing a 20, 30, 40, 50 time prepend means that it definitely won't be used. Well, I have news. If it's the only path in the routing table, it's going to be used, no matter how long the AS path is. Okay, let's say the internet's on average only 5 ASs deep. Maximum AS path prepend most ISPs need to do is about 5 or 6 also. And in fact, some ISPs these days will actually truncate the AS. Well, they won't truncate, they'll throw away prefixes that are more than 15 or 20 ASs long. Okay? So I've thrown in the Cisco version of the command there to chop out those prefixes. Just be aware that some ISPs actually do this. So doing a 50 times prepend is a waste of time. Private ASs should not ever appear on the internet. Like private address space, they shouldn't be announced. So again, the vendors have come to the aid of people who are using private ASs for local reasons in the network. For example, there's the remove private AS command. But it won't remove every instance of a private AS. So if you get a private AS sandwiched between two public AS numbers, that's not going to be stripped out because that's a configuration error. Okay, so you've got to watch that also. Right, let's look at some connectivity problems. The symptoms, this, AS1's announcing a network, 192.168.1/24 to AS2, but AS3 can't see it. So you've got your friend or somebody like that, or somebody your customer's trying to reach in AS3, and, well, you're announcing the network, but AS3 can't see it. This is where I introduced the checklist. You've got to try and set up a checklist to see how we're going to work through this. So AS1 announces, but does AS2 see it? Well, here we're checking the eBGP filters on router 1 and router 2. Router 1's in AS1, router 2 is in AS2. Remember that you need router 2 access to do this. It doesn't mean you send an email to your neighboring ISP and say, "Oi, give me access to your router." You'll ask him, "I'm trying to troubleshoot blah, blah, blah. Do you see this network on your neighboring router?" And if they do, well, then ask them to give you a show output for that prefix. Does AS2 see it over its entire network? Well, here we're checking the iBGP across AS2's network. I mean, in this particular example, it's not needed because we've only got one router. But most ISPs have a large iBGP mesh. Quite often the iBGP is misconfigured. It could be a route reflector problem. It could be a iBGP mesh problem. Things that I've covered earlier in the presentation. Okay? You want to check through some of the things that I've mentioned before about the iBGP mesh. Does AS2 send it to AS3? Here we're checking eBGP configuration router 2 towards router 3 as it filters, or AS path filters, or prefix list, or communities, or something like that causing a problem. Does AS3 see all of AS2's originated prefixes? Here we're checking eBGP configuration in router 3. Maybe AS3 doesn't know to expect prefixes from AS1. But you can't go send you an email to AS3 saying, I'm trying to, because they're going to say, who are you? You're just somebody else on the internet. another of the 16,000 ASs out there. So you're going to need to rely on your neighbor, AS2, to actually work with AS3 to figure out what's going on. Cooperation. Okay? So troubleshooting connectivity beyond immediate peers is much harder. It relies on your peer to assist you. They have a relationship with the peers, not you. Okay? So sending the email saying, oi, is not going to work. It might. I mean, people are generally friendly and cooperative and helpful on the internet. So they may be sympathetic, but they may choose to ignore you as well. Okay, what about this? AS1 announces, I picked a real network. This was my DSL network at home, but, well, it is no more, but anyway, it was my DSL network at home, so it's a bit more of a real example. The ASs still aren't real, but it doesn't matter. So, I'm announcing this to the upstreams in the internet, but the AS3 can't see the network at all. AS1 announces, do the upstream see it? Checking eBGP, blah, 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 blah. Okay? You'll need support of your upstreams to actually try and do this. Is the prefix visible anywhere on the internet? Well, that's a harder ask. Now, this doesn't mean you go sending lots of emails to everybody on the internet saying, do you see my prefix? Right? Next slide is actually going to show how you do that. The looking glass. The looking glass is probably the most valuable, important tool for troubleshooting BGP outside of your network. Okay? There are many networks around the globe which will run a looking glass. They basically let you see a BGP table, and often let you run simple ping or trace routes from them as well. Okay? www.traceroute.org lists all the sites that, well, the collector actually knows of for IPv4, and there's an equivalent site for all the IPv6 looking glasses as well. Okay, mostly traceroute, but some of them will also actually let you see the BGP output from there. Many people still use the original nitrous.digix.net, which is the first looking glass that I was certainly aware of. Okay, so I've got some examples. If you've never seen a looking glass before, well, I just picked the RIPE NCC's RISC service just because it was there. So you've got something like that. You've got various sites you can go to, as you see in the screenshot. That's just, well, I think it's probably about a year or so old now, but those were the sites that they had a presence at. So you could go to any of those routers and have a look at the routing table. And then I went to the RRC01 box at the Links, which is in London, and did a show iBGP for my 203.51.206 network. And there we have output for 203.48.00/14. And it's heard from 3 different neighbors. So the 3 possible paths to it. So that means that this looking glass, I can see that my network is being announced as part of a /14 aggregate. So this AS that was complaining that it couldn't see my network, the problem is more likely to be closer to them. It's certainly nowhere near here, because here they've got 3 possible paths all the way back to Australia. Okay, so the looking glass can see the 14, so the problem must be closer to AS3. And a trace route confirms the connectivity. So here I've done a trace route from the looking glass, and it starts at London, meanders through the US, don't use a reverse DNS by the looks of things, and then goes to the Telstra network all the way up to Brisbane. Okay, so that's the sort of thing that you can do. And you can see from the list, you can do show BGP, BGP summary, neighbors, you can put regular expressions in, you can have the paths. I'm not sure how the version is useful, but you can do traceroute and ping. That's typical of most of the looking glasses you get around the internet. The other place you can go to is RouteViews. I mean, I use RouteViews and the Nitrous looking glass site from my early days because they've been around for a long, long, long time. And RouteViews is actually a real router that you can log into. And, well, when I put the slide together, it had around 60 peers. It could well be more than that. We'll find out in the next couple of days when there's a report on the RouteViews system. Okay, again, www.routeviews.org explains what the project's about. You've got access to a real router, as I was saying, so you can do a show iBGP, or you can do a trace, or whatever else you want to do. Okay, so that's a 2. places you could go. But looking glass and or route views, extremely valuable in letting you find out problems on a global scale for the network reachability. Right, getting back to the here. Right, does AS3's upstream send it to AS3? Well, what you do is you try and find out from the AS path who AS3's upstream is. Because AS3 is announcing networks, so you can find out from them what the AS path is, and then you can try and figure out from their upstream if they can see the prefix. If AS3's upstream is running a looking glass, you can go to looking glass there, and you can see if you can see it. If they're not, then try and go as close as you can. Does AS3 see any of AS1's originated prefixes? I mean, if they can't see your particular /24, can they see anything from you at all? Okay? And that way, there may be some type of filtering that's going on in AS3 somewhere. They may be specifically blocking your network. Who knows? Okay? Troubleshooting across the internet is generally harder, but the tools that you've got are the looking glasses. Okay? Traceroute, ping, BGP status, and so forth, available all over the globe. I have no idea how many looking glasses there are. I mean, to be honest, I haven't looked at the traceroute.org website in quite a while because, I mean, I've got my favorites that I use. They're in my browser, and that's it. That's all I really need to deal with. But I'm sure there's at least one in every country of the world, if not close to that. So it should allow the vast majority of situations to be dealt with. Okay, what about this third example? AS1's trying to load share between its upstreams, but has trouble getting traffic through the AS2 link. Well, you have to try and define what trouble means. Getting a report from a customer saying, trouble, is like, well, yeah, information please. Is the outbound traffic load sharing okay? So you can usually fix this by selectively rejecting prefixes. That's all multi-homing. Okay, that's not really a troubleshooting thing. That's trying to configure a multi-homing. That's easy to fix. Inbound traffic load sharing is harder to do. Okay? And yes, I mean, you can do ASPath prepends, and you can fiddle around with communities and MEDs and leaking sub-prefixes and all the rest. Standard multi-homing practice. Okay, configuration practice. But if they do nothing, then you've got to look deeper. AS1 announces, but does AS2 see it? Checking the filters. We're working through the checklists again. Okay? Same checklists. Does AS2 send it upstream? Checking configuration. Checklist. I mean, I'm going through the process of checking these checklists and anyhow. Does the internet see all of AS2's originated prefixes? We're checking eBGP configuration by looking on other internet routers, which usually means looking at the looking glasses. Okay, they're the best ways of trying to find out what's going on. Okay, checklist. Repeat all of those above for AS3. Okay. Of course, what happens then, people will do that, and then they say, no dear, okay, let's do a huge prepend, and that will solve the problem. But it's not going to. As I said before, huge prepend, if you're the only path, it's not going to make any difference whatsoever. So here, try and break it down to smaller pieces. AS2 is not seeing AS1's prefix, or it's blocking it in inbound filters. Okay? So that's fairly obvious what you've got to try and do there. So you just go to your neighbor and say, oi, fix this. If there's a trickle of inbound traffic, well, if your router supports something like NetFlow, where you can see the actual traffic flow, the source destination address of all the packets coming into your network, switch it on, have a look. Where are the packets coming from? Is it just from your upstream ISP and nowhere else? Then he's probably not announcing your prefix out to his peers. Okay? Look for the clues in some of the other tools that are available. If they claim that they are announcing it, ask their upstream if they'll answer you, or just use a looking glass, because there's bound to be one close by. If there's a light flow of traffic from AS2, but say 50% less than from AS3, use the looking glasses to try and figure out what's going on there. I mean, there may be communities that are setting weights onto the different prefixes. There could be filters going on, anything like that. Or try and use NetFlow to figure out the source address of the packets that are coming in to the network, and you can see what's going on. Okay, example 4. Probably don't quite have time to go through this, but again, looking glasses. Try and figure out layer 2 problems. Right flap damping can cause an issue as well. Okay, right flap damping can cause interesting and unknown things to happen on the network. It can cause situations that may appear transient. They could be causing problems for an hour or so, and then they disappear altogether, and you're not quite sure what's going on. Okay. As I say, many ISPs will actually implement right flap damping. Many ISPs use the vendor defaults. I'm of the opinion that vendor defaults are far too severe. We've got the RIPE 229 values, which a working group of us put together. It's been going for a few years now, but the RIPE 229 is the latest document. And there's opinion that those even are too severe, as was written up in that paper there. Again, try and look at the looking glasses. Looking glasses, you can display the flap damping. This is from the Nitrous Digix Net looking glass. And you see all these entries there that have got history on them. These prefixes have been on the router and have now gone, but we're hanging on to them for historical reasons. Okay? Flap damping can cause issues. Okay? Flap damping can cause connectivity to persist via alternative paths, even though the primary paths have been restored. You've got to kind of watch it. The common symptom is bizarre routing that will just clear up automatically in an hour or so. And you think, well, what nuts going on here? Okay, so try and be aware of that. And there's not a lot you can do about it. You might be able to try and persuade your upstream to clear the damping settings that he has, but it could be more often a problem somewhere else in the wider net. And there's nothing you can do about it, apart from just let it slip by. So just a quick summary of all this. Most troubleshooting is about, experience, unfortunately. This is why I've never really, have been asked to give an advanced troubleshooting tutorial, but as I said previously, advanced troubleshooting, it's like that becomes so specific to each individual network, it's probably not interesting to other people, or if it is interesting, it's hard to apply to other networks, and then some of the advanced problems, maybe the operators who have them are not too willing to share on the particular issues that they had. But anyway, so what I'm really trying to do is give you the basics. So try and build up experience, use some of the simple tricks and concepts that I've mentioned here. Not panicking is really important. Panicking, you tend to end up making more mistakes. So just try and stay cool, go get an ice cream or something like that, and then come back and think through it logically. Check configuration first. Could be a configuration problem. Check locally at first before blaming your peer. I mean, yes, your customers will blame you if the internet breaks, but they don't know how it works. I mean, you shouldn't just go and blame somebody else. Try and make sure that what you've got is fine first. And then troubleshoot. Start at the bottom, layer 1, 2, 3. You may have to do layer 8 and 9 troubleshooting before you look at your own stuff, but try and work through it in logical steps. Use the tools available. So the debugging tools in the router hardware, internet looking glasses, ask colleagues, ask friends on the net, ask public mailing lists where appropriate. Okay? So that's what we covered. Closing comments, blah, blah, blah. Missed that for sake of time. That's where the presentations are. Again, if you missed it at the start, they're on the Nanog website. They're also on that FTP site as well. And that is it. Thank you for overstaying 5 minutes. I hope that was useful. Again, if you have any questions, feel free to send me email or catch me. I'll be here for the rest of the week, including the Aaron meeting. So if you want to ask questions, let me know.
Previous slide back on, please.
Previous slide back up. Okay, thank you.